Okay, folks, welcome to this short tutorial video about Pythagoras' theorem and how you can use it in maths and avoid the common mistakes that are sometimes made. This page we can see in front of us details that Pythagoras is a real person. He was born in Greece in 570 BC and lived until 495 BC. So this man discovered what we're about to learn about. So let's have a look at some questions. I've written down here a three-step process, and these three areas are the three areas that sometimes students make mistakes in. At the end of this video, that will not be you, hopefully. Step one, can we identify the hypotenuse, keyword alert, of each of these triangles? Well, the hypotenuse is found by looking at the right angle. The right angle always points towards the hypotenuse. So in this first triangle, the hypotenuse is a length of 17, and we label that side C. Now have a think to yourselves, pause the video, which of the sides is the hypotenuse on triangle 2 and triangle 3? So pause the video now, have a think about that. If you're still watching, why haven't you paused it? Pause the video. Okay, to recap, that right angle is pointing towards this, which is the hypotenuse, and this one is the hypotenuse here. So first step one, label the hypotenuse as side C. The other sides of the triangle can be called A and B in either order. It doesn't matter which way you do that. So step two, Pythagoras' theorem, which you have to memorize, is a squared plus b squared equals c squared. That's telling us that the square of the two shorter sides is the same as the square of the longer side. And that's going to help us decide whether to add or subtract in our method. So this first question, we'll write down. I can then substitute and replace each letter with the relevant number or term. A is worth 10, so that will be 10 squared. B, we are unsure, we don't know what length it is, we want to work it out. So we'll replace B with the unknown value x. And C, we can see, is worth 17. So you should be thinking to yourself, how can I work out the value of x in that equation? Well, at the moment, x is having this 10 added onto it. We want to undo that process. So in this case, you want to subtract 10 squared from both sides of the equal sign. The reason we do that, that would then leave x squared equal to 17 squared minus 10 squared. Okay, so that then is step two, deciding whether to add or subtract. So pause the video and have a go at question 2. Think about what that would equal. And do the same for question 3. Substitute the values in and see what you get. Okay, pause the video. Okay, so returning, we know that A is worth 5. We can see that B is worth 4. And we're unsure of the value of C. Now, look at the difference in this question. In the previous question, we had to reverse the process to get x to be the subject. In this case, x is already the subject. Therefore, this is a question in which you simply want to add together 5 squared plus 4 squared. So that is a different type of question to this one. Let's check out question 3. Again, replace the letters with the appropriate values. So decide to yourself, is this more similar to question 1 or is it question 2? So look at question 3. Which type of method does it look like, 1 or 2? If you said it's more like question 2, you're right, because look, all we've got to do is add together 16 squared and 12 squared, and that'll get us the value of x squared. So, final step. Step 3, we want a square root to find the unknown length, because at the moment, x squared, if I work out 17 squared minus 10 squared, 189 couldn't be the side length, that's too big. So the final step, which students sometimes forget to do, is you want to square root 189 to get an answer. And the question says 1 decimal place. I'm getting 13.7. Okay, pause the video, try question 2 and question 3. Okay, once you've unpaused the video, you should find that 5 squared plus 4 squared is equal to 41. But don't forget, step 3 says we have to get the value of x by square rooting that. Again, use a calculator. We're getting 6.4. And the final one, we're getting 16 squared plus 12 squared is 400. Again, step 3, don't forget, we want to work out the square root of 400. That comes out as a nice value of 20. We'll put 20.0 down to be perfect. So that's the 3-step Pythagoras method. Step 1, step 2, step 3. Thanks for watching, and feel free to come back to this video in the future.